Seam carving for content-aware image resizing. Digital media today has the ability to support dynamic page layouts. By changing the window or display size, we can change the layout of a document. However, images embedded in a document typically remain rigid in size and shape. Resizing is also important to fit images into different displays. Current techniques, including cropping or scaling, are limited in their abilities to capture the image content. We present a method for content-aware resizing of images. Our technique enables resizing while adapting the image content and layout. This is sometimes called retargeting. We also define a flexible multi-size representation for images that supports continuous resizing. An image can be shrunk in a non-uniform manner while preserving its features, but it can also be extended beyond its original size. Instead of scrolling through images that do not fit in a given display, we gracefully resize them to fit inside the window. For example, assume that we need to change the width of an image. The simplest way to do this is to remove columns of pixels from the image. The best column to remove would be the least noticeable or least important column. We can search for this column by defining an importance or energy function on the image. In this example, we use the gradient magnitude of the image. Next, we look for the column which contains the least energy and remove it. However, using such an approach quickly leads to serious artifacts. Therefore, instead of using rigid columns, we search for connected paths of pixels, or seams, from one side of the image to the other that contain the least energy. This can be done using a simple dynamic programming algorithm as described in the paper in both vertical and horizontal directions. Here's another example of an image, its energy function, and the least noticeable horizontal and vertical seams. By successively removing horizontal and vertical seams, the image can be resized in a non-uniform manner. The order of seam removal in an image defines an order on the pixels of the image. By storing the simple indexing information, we create content-aware multi-size images. In this image, we color all pixels according to the order of their seam removal from blue to red. To enlarge an image, we first calculate seams as if we were to shrink the image. Instead of removing these seams, we insert new seams in these locations. The pixels of the new seams are the average of the pixels alongside the new seam positions. This enables a smooth transition between reducing and enlarging the image size in multi-size images. We have tested different possible energy functions for retargeting, such as entropy, saliency, histogram of gradient direction, and eye movement measurements. The results depend on the given image, but simple gradient magnitude often gives satisfactory results. For certain content, such as faces, where the relations between features are important, we define a simple user interface enabling the designer to protect these image areas. The application is also used as an authoring tool for creating multi-sized images. Note that in this specific example, automatic face detection can be used to identify the areas that need protection. To illustrate another application for this tool, we show a simple object removal procedure. By adding negative weights to the energy of an image, the user can attract the seams to pass through specific areas first. By reducing the size of the image, these areas are removed first, in effect erasing them. To retain its original size, the image is enlarged by using seam insertion. Note that this technique changes the whole image and does not simply erase the objects marked. More examples can be found in the paper and the supplemental materials. Thank you for your attention.